So this is a section 3.7. We skip 3.6. Okay. So 3.7, we're going to spend at least total 2.5 hours on this section. This is about application of calculus. Okay. And that's our motivation. We have to maximize, the profit. For example, minimize the surface area of some geometric figure. Right? For example, if you want to build a water heater, right? First of all, you don't care about the shape, but there is a restriction. It must be cylinder. Okay, it's better. Okay. Then the question is, what is the minimal surface area if for the given volume, right? Then you find out that you solve it for problem using mathematics, okay? And then you find out, this is not what I want because that's like a too big, like a 1 meter diameter and also 1 meter height. That's too big. There's no way you can put it, right? The cross is too small, so you have to change the cost because that is the minimum cost, And unless you really don't care about the space, I still think they should build this type of water heater. So some people put the water heater in the basement, really don't care about the space. Enough space in the basement. So you can have a customer have a choice. Do you want to save $100 or not, right? For the same type of water heater. Yes, the material cost will be much less if we build a water heater using mathematics. Okay, so we're going to discuss this type of problems. Okay, one by one. Okay. Well, so the first problem is let me begin with it. It's just problems in mathematics. Okay, we want to find out two numbers, not necessarily to be positive integers. Okay, two numbers. So first of all, whose difference is a fixed 100, and whose product is a minimum. So we have two numbers, right? We know the difference. Then you also get, you get a bunch of numbers, right? So difference is 100, is a fixed. Then you look at the product. The product, of course, the value of product changes. We want to find those two numbers. The product is minimum. Okay, there's no, all the possible values of product that would be greater than equal to that number. So how do you solve this type of problems, right? In step one, name the variable, right? So those two numbers are called, one is called x, other one is called y, right? And write down the given condition. There's difference is going to be 100, okay? Then there's two variables here. The product is x times y. And x times y has a minimum value, okay? Find the x and y. But when you look at this, you see that actually you just have a function one way because x minus y is a fixed. So this implies y is going to be x minus 100. So when x is fixed, when x is chosen, y cannot be arbitrary. Y must be equal to x minus 100. Okay, so you put it here, and then it will be x minus 100. So you get a quadratic equation. Okay, quadratic. Yeah, you get a quadratic function here. And the product depends on this dependent x, right? And this is a polynomial. It opens upward. So you don't need to use a calculus to figure it out. So the answer, right? And when x equals 0 is a product, this is a product, this is x. When x equals 100, it's here. So the product is 0. So this is a parabola, opens upward. So clearly, this is going to be the minimal value at x equals 50, right? When x equals 50, p has a minimum value. So when x equals 50, y is going to be, right? Y is going to be 50 minus 100, okay? Y is going to be 50 minus 100. negative 50. So the product is a negative number. Okay, product is going to be negative 250, 2,500. Okay, so we solve the problem without using calculus because parabola, quadratic function, I know how to find the vertex of parabola, how to find the minimum value of parabola. Okay, but there are some functions, another quadratic function. You cannot use elementary mathematics to find the absolute minimum value or absolute maximum value. So you have to use calculus to solve the problem. Okay. For example, the next one is also it's pure mathematical problem. Okay. We have a rectangle, right? We have a rectangle. I know the areas are fixed. Okay, 1,000 square. Okay. Suppose, yeah, why we have to solve this problem? You're going to, maybe you have experience, you already tell, right? You have the answer. So you fix here. This is a large area. So you want to put a fence, okay? Build a fence around that. Of course, you want to, if there's a freedom here, put it, if there's no restriction, just a rectangle. Rectangular garden, for example, right? And you want to have 1,000 square meters. But you want to minimize the length of the fence, right? So otherwise it costs much more, you want to minimize the cost. So it's a very simple problem, okay? Find the, so find the dimension, okay? Whose, of the rectangle, whose parameter is as small as possible. Okay. Parameter, right? That's a good problem, This is not, you don't need to work for some company to solve such problem. You just build a fence, right? You have a huge backyard, maybe 2 acre land somewhere, right? But you don't want it such big, you want to put a fence so rabbits will not come into your gardens, right? So you have freedom. You can make a square, you can make a rectangle, but it's do simple mathematics, right? You want to make sure you're going to have a 1,000 square meters area, okay? So, sit down and do some calculation before you go to the market to buy the fence. Okay, so how do you do that, right? This is called X, this is Y, right? So we know that area X times Y is going to be 1,000. Now it could be, 1,000 square feet, that's right, use a different unit. So 1,000 square meters. The parameter, we still use a P. It's going to be 2X plus 2Y. Okay, I want to make this one as small as possible. So actually, you have two variables, length and the width, but they're not completely free. If you let the length to be arbitrary number, then the width must be determined by the equation. So you can solve for y. Y is going to be 1,000 of x, right? So you put it here, 2x plus 2,000 here is of x. Okay, so now this is not quadratic function. The length, the parameter, okay, is going to be given by this complicated function, okay? And clearly, this function, it's interesting if you draw the graph, and this function p goes to positive infinity if x approaches positive infinity or x approaches 0 from positive side, okay? If x approaches positive infinity, then the first term makes the parameter approaches positive infinity. If x approaches 0 from positive side, then the second term, which is 2,000 of x, makes the parameter approaches positive infinity. So if you draw the graph, okay, this is a parameter, this is an x, and looks like that. Okay, so clearly somewhere, right, the p, which is a parameter, has a minimum value, and you just need to find such x. Once x is found out, you can find a y. So all I have to do, right? Just find the critical number. I'm pretty sure at the critical number, the function has a minimal, absolute minimum value. It's clear to me. If there's only one critical number, if there are two, then you have to compare. Okay, so find the derivative. It's going to be 2 minus 2000 x squared, right? Yeah, 2000 x squared. Then I set this to be 0, and you have to solve the equation. Okay, then x squared equals 1000. Then x should be equal to square root of 1000. Okay, now you can do the estimate. Okay, this is x, only one critical number over the interval from 0 to infinity. Okay, so clearly p equals a minimum at x equals square root 1000. Okay, then in that case, y, what is y? Y is y is also going to be 1000 divided by x, which is, okay, and I'm not surprised. It must be square. That's it. It must be a square. Okay, it must be a square. Among all the rectangles, okay, among all the rectangles, the parameter has a minimum value. Among all the rectangles with a fixed area, the square has a least parameter. Okay, so in my opinion, if you want to build houses, rectangular shape of houses, you should build a square type. Okay, that minimizes your cost. Okay, so because the parameter, yeah, for the same area, right? You know, you want to have like 2,000 square feet, right? Area, first floor. The best way to do is to design the house should be square, and then you can design something, you know, partition the rooms as you want. Okay, if you don't care, then don't care. You know, I will visit some country like Hungary. I look at all the houses from the sky, say, oh, the square type. So I try to figure out why is a square type house. Basically just square. Okay, it's different from here, different type. And I guess they're just trying to minimize the parameter of the square, because the parameter determines the cost of the material of the wall, right? Yeah. Okay. So yeah, so maybe you should, if you are the designer, right, architect, then you should design more houses as square type. Okay. All right, so we solved the problem, right? It must be square, and we prove that in mathematics. This has a minimum list value. Okay, the parameter has a list value. So now I'm going to try to solve another problem. It's a three-dimensional problem. This is two-dimensional, right? The three-dimensional problem is if what I'm going to do is, yeah, let me write down the problem. Okay, if 1,200 square centimeters of material is used to make a box, okay, the box, there is a restriction here. A box, the base is a square, okay, and the box is also an open on the top. Okay, clear. So find the largest possible volume, the values of the largest possible volume of the box. Hmm? Oh, the material, you know, the cost. If you look at just yeah, find the largest possible volume. Okay, so you see, the cost of the box. Okay, the material cost depends on surface area of the box. Okay, and but the top is open. Okay, the top is open, and let's call it. The top is open. Yeah. And so when you design the box, right? And there's a, this maybe the box is a metal box, right? Right? And you want to know the surface, the top is open. It's like some kind of container, okay? So the cost of the material would be equivalent to, proportional to the surface area of the box. And that is fixed, we just, for each box, we can use 1,200 square centimeters of material. Okay, then the box must be square type, so we want to find a dimension such that it holds maximum volume. Okay, that's clear, right? So we have to design. But before we design, we have to calculate. Do some calculation. So the base, that's called A. The height is H, right? Right. We don't know. We only know the base is a square. So name the variable. Draw the picture. Name the variable. So surface area. We have to calculate surface area using A and H. Okay. How many? The face at the bottom is A square, right? Then on each side, A times H. How many sides? 1, 2, 3, 4. 4 sides. 4A times H. That total surface area will be 1,200. Right? That's a given condition. Okay. And the volume is going to be A squared times H. That's a volume. So volume depends on two variables. Actually, the volume only depends on one variable. Okay, because A and H are not arbitrary. Okay, so how do you do that? You want to solve for A or solve for H? I think solve for H first, because solve for H is easy. You don't need to use the radicals. Okay, so solve for H. What is H? H is going to be 1,200 minus A squared divided by 4A, right? You can simplify it. A cancelled out. Now this time you get polynomial of degree 3. Okay, and A is not a. Is there any restriction? A looks like no restriction, but A cannot be too large. I think A cannot be too large. Clearly, A is greater than equal to 0, less than equal to square root of 1,200. Otherwise, H would be negative. Okay, it's impossible. So A is between those two. So you get a function, a polynomial defined, polynomial in A, defined on the closed interval. It must have an absolute maximum value. How do you find absolute maximum value? A function, right? On a closed interval, you look at critical numbers, look at the end points, okay? And at the end, two end points, the volume is 0. So clearly at A equals 0 or square 1,000, right? The volume, okay, the volume is going to be 0. So, but the volume is positive. If you draw the graph, this is the volume, this is A. And here's A, here's the square root 1,200. This is 0. I'm pretty sure this is a graph, okay? Somewhere it has maximum volume. Okay, it's polynomial degree 3. Okay, all I have to do is find the derivative. Okay, find the critical numbers. Okay, let's find the derivative. dVdA. If you take 3 out, I think it's be 400 minus A squared. Okay, that's it. So if I set this to be 0, A is going to be plus minus square 3, plus minus square root of 400, then just positive 400, because we're looking for critical number in the interval between 0 and the square 1,200. Okay, it's 20. So 20 is the only critical number inside the interval. And clearly, the function, the volume function has a maximum value, absolute maximum at this number. Okay, clearly, I should say, I'm not done yet. V has maximum value at A equals 20. Okay. You only have one clear number, and then the volume is equal to 0 at 2 endpoints, and between those 2 endpoints, positive, and only one clear number. Of course, the function has absolute maximum value at 20. Okay, when A is 20, you can find H, right? H is going to be 4 times 20, and 1,000 minus 20 squared. Let's do the calculation. 1,200 minus 400. That's going to be 800. Okay. It's 10. All right, 10. Good. The height should be 10. Okay. So you get a picture here. It's going to be okay. A equals 20. A equals 20. H is going to be 10. So the volume, the largest possible volume you're going to get is going to be 20 times 20 times 10. Okay, it's going to be 4,000 cubic centimeters. Yeah, 4,000 cubic centimeters. All right, so let's go back to the problem again. How do we figure out this? First of all, based on the given information, you draw the rectangular box. Okay, then it's a square base, so you make the space square, and so you mark A and A. The height is H. Then you write down what is given. Right? Write down the given information, which is the surface area. So surface area is A squared plus 4AH equals 1,200. Then you write down the expression for the volume. It involves A and H, so you have to replace H, okay, by something in terms of A. Then you get a function of a single variable, then you are able to solve the problem here. In Math 261, you have to deal with multiple variables. You can still find the maximum value or minimum value. Okay, some quantity depends on more than one variable. 2 variables, 3 variables, that's possible, right? Even 1,000 variables or 2,000 variables, because we have to deal with that's bigger data time, right? So lots of things involved. Yeah, it's not easy. Then you have to find the maximum value, minimum value using calculus. Okay. Let's try another problem. Okay. So this is a cylinder. Okay, this is a problem I discussed at the very beginning. Okay, to make this simpler, so cylinder, just like a water heater, for example, right? So we assume that the volume should be 2,000 pi cube meters. That's the fixed. Okay, find the dimensions that will minimize the surface area. Okay, so the parameter you're going to use is the radius and the height. I wish you to set up the given information in terms of I and H, and find the quantity which which represents the surface area. Okay, please do it. Cylinder. You shouldn't know about cylinder because there's a formula in there, right? You studied that in high school. So yeah, can you express the surface area in terms of I and H, or in terms of only one variable? I think still talking about water heater. I still think why the water heater does not meet our conclusion, because if it's too wide, right? Like the height equals the diameter. It's very difficult to carry. Right? That's the reason. Yeah. I was trying to even move a 50-gallon water heater by myself from the basement upstairs. Too heavy. It cannot carry. But a small one, like a gas water heater, you can hold it. It's like this ceiling, very tall. It's easy to. So let's solve this problem. Yeah? And I think we're going to prove that the best one, which minimizes the surface area for the given volume, should be the diameter should be equal to the height, I think. Okay. Step 1, draw the picture. I'll give you the picture. Right? Step 2, name the variables. Step 3, write down the given information in terms of these variables. Then step 4, express the quantity you're going to minimize or maximize in terms of these variables. All right, let's do it. Step 1. Yeah, you already finished the picture. So write down the given information. The volume. Volume is the base area times the height, which is 2,000 pi. Okay. Then you have to find the surface area. You have two disks plus this area, the surface area, right? It's 2 pi r, that's circumference, times h, that gives this area. So total, you have that, how many terms, right? Actually, you got 2 pi r squared, 2 pi r h. All right, now, I think you need to solve for h from this equation. So 2 pi r, and h is going to be what? It's going to be 2,000 divided by r squared. Okay, h is going to be 2,000 divided by r squared. So now you get a single function in r, a single variable. Okay. For the same reason, if you draw the graph and the picture looks like that again, okay. When the radius is sufficient small, the area will be sufficient large. Okay, because the height must be very high. The height must be very large, right? So it's obvious to see that. So clearly, there's somewhere it has absolute minimum value. So you just need to find out the derivative. It's going to be 4 pi r minus, I think it's 2 pi here. Here's r squared, 2,000. Okay, so you set this to be 0. Okay. I think after simplifying, you get 1,000 divided by 2 squared. Okay, I have to get rid of 2 pi. So r cubed equals 1,000. That means plus r equals 10. Okay, so when r equals 10, what is h in this case? H is going to be 2,000 r squared. R squared is 100, so h is 20. All right, radius is 10. H, the height is 20. How does it look like? It looks like that. Okay, so cylinder and diameter. Whoa, right? It's a 10. Here is 20. So 10, 10. Nobody will build a water heater like that. It's very difficult to lift. Too big. You cannot hold it. Unless you put some handlebar on the top and then 2 people lift. But still takes more space. So, well, put it in the basement, it may be okay. But this pretty low. Usually want to put it pretty high. So it's not the best design. Then any other type of a cylinder will get, will use more surface area. You want to hold a 50-gallon water, for example, same fixed volume. Then you have to calculate the cost. Okay. So this will minimize the cost. Now that cost involve lots of things. This is just one, just about the material for the surface. There are also some fixed costs. It's independent of the shape of the cylinder. Okay. There are some problems from business, all kinds of and from the design of the airplane, when you put the engine some location and how the surface of the airplane, the body, right? And how do you make it? It's a question. You have to minimize like a friction, resistance, all kinds of things. Okay, so it's more and more complicated. That's why I say if you want to study fluid mechanics, you must be very good, super good in mathematics. Otherwise, don't think about it. Okay, you're not going to do well if you. I just want to say that. Okay, fluid mechanics that involves more mathematics. All right, but being a farmer, probably calculus is enough. Just kidding. So let's do another problem. The farmer will have to do. Okay. So this is a one side, maybe river. Okay. So I'm going to build a fence. I'll use a fence. Okay. So the point is, the fence. I don't need the other side. Okay. So this, I know this area should be 1,000 square feet. Okay. So I want to find the dimension. Okay. Find the dimensions. First parameter is as small as possible. Okay. All right, so only 3 sides. The parameter means the fence. Only 3 sides. Okay, only 3 sides. Other side you don't need. So just the 3 sides. Okay, so this other side, we assume that just you don't need a you don't need a fence. Okay. Okay, how do you solve them? Draw the picture, right? Sometimes the picture is not given. So draw a picture. Name the variable. So this is x, this is y. And don't forget that's x, y here, right? Area. Area is fixed. X times y, which is 1,000 square feet. Parameter. Parameter is x plus 2y. That's it. So we do this. We will do the similar problem, but this time it's not rectangle. One side is open. Okay. Okay. So from the area, you get x or get y. So y equals 1000 divided by x, and you put into here. So the parameter is going to be 2. Y is going to be 1000 divided by x. So you get something equation like that. Okay? It's a function of x. And if you draw the graph, if this is a p, this is x, still looks like that. Then we have so many problems like that. Okay. And then definitely somewhere there is a minimum value, absolute minimum value. You just find the critical number. Okay. You know, if I put the problem on the test, maybe I change it to 2000 square feet. So that gives you a little bit easier for you to find it. Yeah, integer values. So set it to be 0. X squared equals 2000. Now x should be square root of 2000. Okay, that's not a integer, irrational number. Okay, once you get x, then y is going to be 1000 divided by square root of 2000. Okay. And what is the difference? I think you can multiply the denominator and numerator by square root 2000, square root 2000. So you will get 1000 divided by 2000, 1/2. So clearly, y is going to be half of x. So the graph looks like that. Consists of 2 squares. Consists of 2 squares. Okay, this is y, 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 and the x. Okay, x is going to be double of y. Okay. And there's similar problem. If I put the bar between those two, you know, sometimes you have 2 different type of animals you want to put them, right? And you want to separate them. So you want to put another fence here, right? In that case, the problem have to be changed a slight different. And there's a similar, okay? So my question, you know, if you understand, see, when you get home, okay, look at the problem. I hope you still remember, you know, write down all the details, but you look at the problem, you understand the problem, right? And you're trying to cover the rest of that. You do it by yourself, okay? And then you compare, you know, with my one, you know, and including the notation. Some students use always the wrong notation. So use, yeah, then make sure it's clear enough to everybody. Yeah, then to see if you get the same answer or not, okay? And the good exercise is, this side is still open, right? So you want to put another fence in the middle. Okay, that's possible. Sometimes you have two different type of animals. You don't want to mess up. Okay, then cows and the sheep, right? So then find the dimension. So minimize the total length of fence, right? Okay. So here still the area is going to be 1000 square feet. Okay, and then yeah, find the. I'm not going to do that. But you can a good exercise. Okay, this side you don't need it, right? Yeah. Find the dimensions such that the total length of the fence is as small as is minimum. Okay, So it's as small as possible. Yeah, maybe I put 2 bars in the middle. You know, that's yeah, but you should know the idea, okay, how to set up. It does not require lots of geometry here, just a rectangle. Everybody knows that rectangle, right? The next problem, maybe, and not everybody can do that because it's not a rectangle, okay? It involves more deep geometry. Okay, so this is an exercise, okay? When you get home. So my next problem is, I have a circle, okay? I can assume that I have a circle with radius 1. So find the dimensions of the isosceles triangle of the largest possible area, okay, that can be inscribed in a circle of radius 1. So there are many, you know, there are many isosceles right triangle there, right? So I can draw many of them, you know. Let's say this is the first one. This is the arbitrary one, right? This could be also an isosceles triangle, right? Yeah, there are many versions. Maybe this very tiny one, right? So there are so many different type of isosceles triangles inscribed in a circle. Questions among, yeah, which one gives the largest possible value? Definitely, there's one, you know, of maximum maximum area, right? Can we determine the dimension? Okay, I give you a couple minutes to test how good you are geometry. Okay, this is another just a simple geometry like rectangles, you know, triangles. It's triangle, but it's inside circle. Okay, the dimension of the triangle yeah, let me label it. This is A, this is A, and the base part, let's call 2B, make it easier, okay? So you have to express the area in terms of A and B. And A, B are also not arbitrary. If 4 vertex of triangle touch the circles, otherwise it's not maximum, you know, this doesn't have a largest possibility of the area. Step 1, find the relationship between A and B. If you're able to do that, that means your geometry is super good. Okay. Yeah, addition I have to draw it. Otherwise, I mean, how do you know that every day, right? The radius is 1. And all right. Yeah, I'm going to look at this triangle, the small one. Okay, I'm copy here. So radius of the circle is going to be 1. So this side is 1. 1, right? And then here's the b, the base half. That's 2b divided by 2. So how about the other side? The other side is going to be what? It's going to be the height of the triangle, which is h, right? So h minus radius. What is h? H, you can apply the Pythagorean theory to the problem, right? This triangle, here's a b, here's a, here's h, right? So clearly, h is going to be square root a squared minus b squared. Okay, so that is h. Okay. So a and the b are given. All right, so now we have a and the b, right? H. So this is a right triangle, right? So this is a right triangle. So we need to apply the Pythagorean theory to get relationship between h, right? So you see that h minus 1 square plus b square equals 1. Okay, right? And so my question is, what variable I'm going to use? Okay, actually now we have 3 variables, right? A and B and H. Okay, so the area of the triangle, right, is going to be half of 2b times H. So what is b times H? So I think I'm going to express b in terms of H. I really don't need to know the A. Okay, so that is going to be yeah, b from here. See, b squared equals h one. So it's going to be square root of 1 minus h minus 1 square times h. Okay, so the area of the triangle can be viewed as a function of the height, okay, by this formula. Okay, and what is the possibility for h? I think h is always greater than 1, right? Yeah, h is greater than 1. H is less than 2. So there, there are some values for h. Okay, so we can, yeah, h is definitely greater than 1 less than 2. Okay, from the picture. Okay, So anyway, this is h is a function of a is a function of h. Then you just need to find the after you simplify, it's going to be 2h minus h squared times h. Okay. You can also take h out. Then there's h times h is 3 over 2, and the 1 minus h to the 1/2. Okay. So this is a function of h. It's a pretty strange function. And let's find the critical value. I need to take h out. Okay. So what I'm going to do is take this out, take this out. So I will get h to the 3 over 2, 1 minus h to the negative 1/2, and that's simplified. I will get, no, this 1/2, take 1/2 out. So I will get 3 over 2, 1 minus h, okay, and here's h times 1/2, negative 1. Okay, so you get a linear term. So if you take 1/2 out, 3 minus 3h minus h let me double check. I think there's a negative sign here, okay? Let me double check, okay? This is a half. Okay. Yeah. So we get 3 minus 4h okay. So set this to be 0. You will see that h is going to be 3 over 4. Okay. So 3 over 4 is going to be the a critical number. Okay. But we also see that the function, the function, yes, 3 over 4 is not a critical number in the interval. Yeah, let me double check my computation. I'm not sure it's correct or not. So this is between 1 and 2, okay? And find the derivative, am I right? Because I do not get the critical numbers, okay? Okay, so let me double check why I don't have a critical numbers, okay? So I have a negative 1 here. It's funny, right? 3 minus 3h minus h minus 4h. So this is not even, yeah, it's not in the, okay. So that means, did you see my mistakes? Because I'm supposed to get the h is greater than 1, right? So this is a function. I want to find the max value and the minimum, okay? So this is a function. I don't see the sign mistakes. All right. So that means the function, what is the largest possible value for h? The largest possible value for h is 2. Okay. When the isosceles triangle shrink to the one line, the height is 2. The smallest possible value for h, this could be, yeah, h could be less than, yeah, I think that there's a, oh, we assume that the h could be less than even 0, less than 1. If h is less than 1, how can I get the triangle? I assume h is greater than 1, so you get drawn. If in that case, okay, if in that case, so this is a picture, okay. And this is a 1. This will be 1 minus h, okay? So this will be b. I think it's the same formula here. It's the same formula, okay? So the same formula, 1 minus h squared. So it doesn't matter whether h is greater than 0 or not, okay? So h could be from between 0 and 2. Okay, look at if h is a parameter, okay? So the two picture here. One is the second picture here. No, it's a b minus h is this side, okay? Because radius is 1. 1 minus h is going to be the edge length of this side. So 1 minus h squared plus b squared equals 1 squared. You still have the same identity, okay? As yeah, okay. So that means the function has critical numbers and h equals 3/4 and 1. 1 is also critical because the function is not differentiable at that point. Okay. Then you look at the area for area formula. Area is going to be what? Area is going to be no, I think I find the mistakes here. The mistakes is when I take an h out, I missed the 2 here. That was, yeah, the problem. Okay, it's 2 minus h. Yeah. Okay, it's 2 minus h, and yeah, let's differentiate. It's 2. It's 2. Okay, the only difference here is 2. Okay, so I got yeah, it's 2, 2, 2, 2, 2. Yeah, then it's correct. Okay, so that is going to be 6 minus 3 minus 1. Okay, that's okay. Yeah, so h will be 3/2, but we still have 2 critical numbers. Okay, so this is going to be, yeah, 3/2. Okay, 3/2, not 3/4. So we have 2 critical numbers because the function, no, 1 is not going to be critical number anymore. So only 1 critical number. Yeah. Okay. Over in the interval. Okay. In this interval, that's only in the interval. This is only critical numbers. Okay, great. All right. So this is only critical numbers in the interval from 0 and 2. Okay. And clearly, when h equals 0, when h equals 2, it's also 0, right? When h equals 0 or h equals 2, the area is going to be 0. That's why the area is going to be maximum at h equals 3/2. Okay, so that is a picture. So you find the dimension, you can determine the, yeah, only when the triangle here, this is going to be 3/2. that gives you the largest possible area of the triangle. Okay, so you gotta just careful, yeah, when you simplify the equation and you find the derivative, okay, and if you draw the graph, this is area, this is h, and that is going to be 2. Area is going to be 0, here's 2, then, so what you get here is going to be some picture like that. Okay, this is area. So somewhere here, 3/2 gives the maximum value. Okay, you only find the one critical number, which is 3/2. So the function could be complicated. It's not like a polynomial, it's not rich. You know, it's not like x plus 1 of x. It could be a function like that. You see, could be a function like this. Okay, so that's the reason sometimes we see a function like that. You know, we have to find maximum value of this. You know, where this from, right? Actually, from this particular problem. Okay, so if we consider isosceles triangle inside the circle, then you end up with a function like that. Okay, so there are some problems difficult, some problems are easy. One problem from the test before, yeah, let's go back to this problem, is I'm not going to build a square base. What I'm going to do is, I know this is a rectangular box. I know the base, this side will be 2a, other side is a, okay? So it's a special rectangle, okay? And the height is h. We know that the volume is fixed, is going to be still 2,000 cubic centimeters. Set up, yeah, set up, right? Find the a and the h such that, okay, the surface area is as small as possible. Okay, so very first step, you write down the volume formula. It's 2a times a times h equals 2,000, right? And then the surface area, you have to figure it out. The base part is 2a squared, right? The top part is also 2a squared. Okay. Then the side, this side, h, right? 2a. So you have to calculate all the side, right? Plus 2ah. The back side is 2ah. How many sides? 6 sides, right? 4 already. Yeah, the one on the top, the one at the bottom, the one in the front, and the one the back side. Okay. Total, yeah, I'm confused. 2h, and then a times h on the side. Okay, total 6. Left to right, top and the bottom, front, back. Total 6. So add them together, you get 4a squared, and how many ah? Like 6 ah. So you get this. You want to minimize the surface area. All you have to do is just replace h by 2,000 from here, right? And the 2a squared. Okay, that is h. Then you simplify to cancel it out. So 6,000 of 8. Okay. And then you find the minimal value, find the critical value, then you solve the problem, right? So this one, again, if you draw the picture, that's a that looks like that. Okay, so there's somewhere at the critical number, it has a minimum value. So you find the critical number. Okay, 4 times 2a minus a squared, 6,000. It set this to be 0. Okay, then you get a cube. It's going to be 6,000 divided by 4 times 2. You have to simplify, right? 4 times 2, that's going to be 8. Yeah, let's just simply write this. Okay. So you can the problem is that you cannot express a this is a third root, okay, of that number. Okay, and I think we can simplify a little bit. The third root of 8 is 2. The third root of 6 cannot be changed. The third root of 1,000 is going to be 10. So that's why it's a 5. So you get the exact value of this. Then we solve the problem. Okay. And once you get determine x, you can determine the h. I forgot the h. H is 2,000 divided by 20a squared. 2a squared. H is going to be 2,000 2a squared. Okay. So 1,000 a squared is 5 cubed root of 6 squared. I'm not able to simplify this. Yeah. So just leave it like that. So you find the dimension of that of this problem. Okay. So there are basically only a few problems like that. Most common problems like a cylinder and rectangle type of problems. Okay. You know, if we have to deal with like a isosceles triangle in the circle, that those are it requires much more geometry. So we probably don't put that on test. But you should know how to deal with this kind of problems. Okay. I go back to my office.